Okay, hello everybody. My name is Susan Murphy. I am the HeatSmart Melrose coach, and I think a lot of you on here know what HeatSmart is. It's a program we've been running for probably 6 months or even more now, where Melrose has partnered with both the state. We actually have Jacqueline Gill here from Mass CEC, so we have the Massachusetts Clean Energy Center as part of this program. Their consultant Cadmus. We'll have Jeremy Koo here speaking. And we've partnered with installers of clean energy technologies. And this particular program is about heat pumps. So we have our heat pump installers available tonight to talk to you. We have Joe Wood from New England Ductless and Larry Lessard from Achieve Renewable Energy. So the goal tonight was, I know this has been a very successful program. We've have over 100 heat pumps being installed in Melrose through this program. And I also know that a lot of people have previously had heat pumps installed or are considering doing it in the future. And from my experience talking to people is people do have some questions about sort of how they work differently from existing heating systems, or if you can keep your existing heating system, how you use it in conjunction with your heating system. And so we thought, while we have these experts on tap, we would do a little webinar, have them talk about the differences and what they tell people about how to use your heat pump system, the kind of questions they get, and also have an opportunity for you all, whether you have a system or are considering getting one, to ask questions of them, the experts, about using these systems. So the way we're going to do this is, first we're going to have a short presentation from Jeremy Koo of Cadmus about generally how heat pumps are different from sort of conventional heating systems and what that means for how you use them. We're going to hear from Larry Lessard, who is our ground source heat pump installer, about some specific things with respect to those systems, and then from Joe Wood, who is our mini split air source heat pump installer, about the systems they do, what the kind of issues people that they, when they do installations, the questions they get from people. And then we're going to have an opportunity for you all to ask questions. We can do that in writing through the chat functions, or so I'll be monitoring those, or we'll have an opportunity for raise your hand at the end. But we're going to start with the presentations. So Jeremy, are you ready to go ahead with the presentation?
Yeah, let me see.
And then I think I need to make you the host for you.
Yeah, I was going to say, yeah, it's
is that okay?
Yep.
All right, are you game? I think that means that you then get notified if people are still trying to get in. Hopefully we have everybody who wants to be part of this, but just so you know, if you get a little notice that someone's in the waiting room, you can let them in. All right. Okay. All right, so we'll have Jeremy do his presentation, and then we'll go from there. Thanks, Jeremy.
Great. Just let me know when you can see my screen.
Yep, can see it.
Okay, great. So thanks everyone for joining us tonight. Susan said I've been supporting the HeatSmart Melrose program through my role as a consultant at Cadmus, and so Susan asked me to give just a bit of a primer on the ways in which we spent I think the last getting on close to a year now talking about promoting heat pumps and other clean heating and cooling technologies to residents and businesses in Melrose. And now we're with over 100 homes that have moved forward with installing systems and other heat pumps in the city. We are putting on this webinar just to help make sure that everyone is using them to the best of their using their heat pumps in ways that maximize their efficiency and help realize the benefits that they were seeking in installing these systems in the first place. So I'm going to give sort of, I guess initially just talking about some of the differences between heat pumps and boilers and furnaces, and maybe a bit of a review for some of you all, but it's important to help understand why some of the best practices for operating these systems are why they are. I'll go through some other recommendations that experts and programs, manufacturers, etc., have compiled over the years, as tens of thousands of heat pumps have been installed throughout the Northeast over the last several years. And then I'll turn it over to Larry and to Joe to give some additional detail on their technology specialties afterwards. So the first thing to I guess drive home is, of course heat pumps are not boilers and furnaces, but there are several fundamental differences between these technologies that impact how you can best use them. First of all, boilers and furnaces, well, at least in the Northeast, in some cases they use electric resistance, but boilers in the North and furnaces in the Northeast combust fossil fuels to provide heat to the home and then distribute that heat throughout the home. Heat pumps instead transfer heat from the ground or the outdoor air to heat the home. Boilers and furnaces also typically are either on or they're off. They're either providing the rated heating output that they're designed for, or they're not. There are, of course, two-stage boilers or modulating boilers and furnaces, but those tend to be much less common. By comparison, heat pumps, cold climate heat pumps, and ground source heat pumps have what are called variable speed or modulating heating output, or have multiple stages that allow you to run the heat pump from providing the maximum amount of heat that they're designed to provide all the way down to 10 to 15% of the amount of heat. This allows the heat pumps to run more continuously and keep providing heat throughout the winter, or in the summer, in continuing to operate, they're able to provide a more consistent dehumidification, as opposed to boilers, furnaces, and central air conditioners, which typically are just either running at 100% or not putting out any heat. Boiler and furnace efficiency generally is maintains close to what the rated efficiency is. The AFUE can be anywhere from 70-something% up to 95%, and that efficiency is maintained when the boiler furnace combustion has reached a steady state and the heat is being provided. Heat pump efficiency varies, however, depending on the heating output and the outdoor conditions. That is the difference between whatever the outdoor heating reservoir is and the indoor temperature. Heat pumps are, as I'm sure most of you know, more efficient when they're in more mild temperatures, and they are less efficient during colder conditions when they need to operate at maximum capacity. Because of the nature of how heat is provided to the home, combustion systems like boilers and furnaces will typically rapidly warm up the space and then switch off. Most boilers and furnaces are, I'm sure folks who have lived there will, as my furnace in my home just turned on, it'll probably run for about 5 minutes before turning back off. Heat pumps, on the other hand, because they are operating through heat transfer as opposed to through combustion, are going to more slowly warm up the space and want to run continuously and want to maintain that temperature and maximize efficiency. Additionally, part of the reasons for this is that boilers and furnaces are frequently oversized for the needs of the home. They're, the smallest boiler or furnace you can buy is often more than you would need in a small home. And whereas heat pump installers, because of the way in which costs scale up with increased equipment size, and the benefit of ensuring that the heat pumps are right-sized and able to modulate their capacity, heat pump installers like Joe and Larry focus on ensuring that the equipment is right-sized for the space. So with those all in mind, what that means is there are a few ways in which the fundamental differences between the sort of traditional equipment and heat pumps affect the best ways to operate these. The first thing is thermostat setbacks, or reducing the temperature of your home overnight to save energy. Um, it's a good practice in general. It started being promoted a lot during the 70s, and many people continue to follow these practices now. The DOE estimates that setting back your home for 7 to 10 degrees for 8 hours a day can lead to about 5 to 10% of savings in your energy bill when you're using a boiler or furnace. The reason this works is that when say you set your thermostat back from 70 to 60 overnight, in the morning, the amount of heat that's provided by the boiler and the furnace is consistent with the amount of gas or oil or propane that is consumed. There's not a significant impact on the efficiency of the heating system if the home is colder, or the temperature outside is colder. And since most of these traditional appliances provide more heat than is needed to keep the home at a comfortable temperature, the home can be brought back up to the desired temperature during the day, or when you get home, more rapidly. Setbacks are not so great for heat pumps, however. Regularly setting back heat pumps can lead to a number of issues, both with the performance in how well it is providing heat to your home, as well as actually reduce the efficiency of your system. The when as I mentioned before, when a heat pump's compressor has to run at the maximum capacity, this is when it is least efficient. That means if you were to set back your thermostat again from say 70 degrees to 60 degrees, and then in the morning when you wake up, bring the home back up to temperature, your heat pump is going to need to run at maximum capacity to be able to bring the temperature of your home back up to your desired temperature. This means that it's going to be running at its least efficient for a prolonged period of time, again, because heat pumps are not going to transfer heat very rapidly. And in some cases, depending on how they're set up, and if they have backup electroresistance, the controls of the heat pump may even use the backup electroresistance to help bring the home back up to temperature more quickly. For air source heat pumps in particular, if you're doing an overnight setback, the coldest hours of the day are in late night, early morning, which means that if you are doing at 6 a.m. having the heat pump move your home back up from 6 degrees to 7 degrees, it's trying to extract the most heat possible at the coldest point of the day, which can further reduce efficiencies. If you have a ductless heat pump, that is, you have multiple indoor units in the home that are zoning the home. If you're frequently setting back the system or setting back individual units, this can lead to some unevenness when recovering temperature because you don't have a central distribution system. This sort of counterintuitive interaction here has been documented by a number of studies. Field studies. I've referenced one here that takes a look at about a dozen of these studies, and as well as installed meters on homes. And generally, the findings from a lot of the literature have indicated that frequently setting back your heat pump, while you may think it is actually saving you energy from having to provide less heat to the home, is likely to increase your energy bills in the long run by having your system run less efficiently during the periods that it is operating. Again, heat pumps, we have a great technological offering here in that they can operate in a variable speed capacity. Those systems are most efficient when they run continuously and at partial load, not when they're ramping up to their maximum capacity. So for heat pumps, the best practice for daily operation is to just set it and forget it. if you turn off wall units when you leave the room as well, this can lead to some uneven temperatures. And certainly if you're gone for a prolonged period of time, you're gone for several days, you should set back your home, and that will set back your thermostat, and that will help save energy. But daily setbacks, setting the temperature down when you leave the home for work, or when you go to sleep, those are the sorts of behaviors that, while they're great for saving energy with a conventional system, are not so great for heat pumps. If you have a ductless air source heat pump, I'm sure some of you have seen the remotes on those indoor units have a lot of buttons on them. There are a lot of settings that are available for controlling your indoor units. We generally recommend that you first set the fan to auto speed and adjust as needed. If you need to get the heat, push heat or heated or cooled air further throughout the room, make adjustments there. Make sure that you keep your mode on heating or cooling depending on the season. If you have it on auto, there are some systems that will provide cooling if the room happens to overheat in the shoulder season, or start heating when you actually are when the home gets overcooled, depending on if you have a lot of sunlight in the room. So keep it on heating mode in the heating season and in cooling mode in the cooling season. The thermostat number that you have on the equipment may be higher than what you expected when you had a conventional system to stay just as comfortable. And this is just a product of the fact that if you have a wall mounted unit, it's mounted high on the wall, and heat rises, and so it may just be a few degrees higher where the sensors are for the equipment. And also test, again, the wall-mounted mini-split design was designed originally to provide cooling, and it directs cool air into the room. Naturally, when you have it providing heat, you don't necessarily want that heat to be hot air to be blown upwards. A lot of these indoor units have the ability to adjust the direction of the grates and the airflow, and so you want see how if you're having some issues with comfort and distribution, directing the cold air up and the hot air down. And the last thing that I'll get into is just keeping your system well maintained. There are filters in every indoor unit for ductless air source heat pumps. There are also filters in your ductwork if you have a central air source or ground source system, or filters in the unit or adjacent to the unit itself for some ground source systems. Depending on how much dust, dirt, pet hair, etc., it is worth checking on those filters, cleaning and replacing them every 2 to 6 months, or even more frequently, depending on the condition of your home. And obstructed filters can lead to increased noise, reduced airflow, and reduced comfort and efficiency. For air source systems, you can make sure you keep the outdoor unit clear of snow, particularly during snowstorms, and ensure also that you keep it clear of leaves and other debris that can accumulate over the course of the year. Additionally, get your heat pump checked out by a servicing professional. Depending on the manufacturer, the recommended time can be anywhere from every year to every few years, but it's certainly worth, if you are not, particularly if you're less comfortable maintaining the indoor and outdoor equipment yourself, hiring a trained professional to do so. Some equipment, like the equipment that Larry installs, allows you to the installer to diagnose operational issues, and conduct an assessment of the system from afar. So that can also save a visit, though generally otherwise the equipment kind of runs without too many issues. With that, I guess I will pass things over to Larry. I know you had a few slides that you wanted to talk through, and then we'll go over to Joe.
Before I do that, I just said thank you so much, Jeremy, for that presentation. That was great. And yeah, so we'll pass it on to Larry Lassard. He is with Achieve Renewable Energy, which is our ground source heat pump installer. And he's been great to work with. I have had the good fortune of having a ground source heat pump installed at my house, and so I can definitely vouch for Larry. Before we do that, Jeremy, have you been letting people into from the waiting room, or?
I have, yeah. We're
Okay,
up to 33 now.
great. All right, so I'll let you keep control of it so you can show Larry's slide. So Larry, do you want to get in here and
Sure.
give us some specifics
Thanks,
on your systems?
Yeah, thanks, Susan. Thanks, Jeremy. I had contemplated my entire presentation being one slide, but then Susan asked me to add some things about our monitoring system. So I'm going to have more than one, but not a whole lot more than one. You can go to the first one, Jeremy. So I'm going to explain how to set temperature for your ground source heat pump system, and then talk about remote monitoring and control. Before I forget, Jeremy had mentioned changing air filters. That is the only maintenance on our systems that homeowners need to do. And it's something we train them in. It's pretty easy to accomplish. And it is important. Our thermostats will remind you when it's time to change your air filter. Okay, next slide. So here's the one slide I was going to use. Just set it and forget it. Here's our famous Ronco Showtime rotisserie oven that was so popular years ago before people had hot pots. But it is appropriate to just leave the thermostat where it is. Next slide, please. As Jeremy explained, temperature setbacks do not save electricity with ground source heat pumps, and they actually make the system less efficient. Our systems that we install are variable speed, and they're, as Jeremy pointed out, they're highest efficiency at the low compressor speeds. But if you set the temperature back, the equipment's a little bit like a golden retriever. It's going to try to please you, so it'll crank up and go as fast as it can to get you back to the temperature you want. Now, if you're talking about a particular space that you like a different temperature during the day, like your sleeping quarters, cool down a little bit at night, that's perfectly fine. You can do that. But as far as the whole house goes, not necessary. With variable speed equipment, I mean, it reduces efficiency. It's a little bit like driving your car, because your car is variable speed, and you can drive it, get on the highway and drive it 30 for 5 minutes, and then 80 for 5 minutes, and then 30 for 5 and 80 for 5, and keep doing that all the way to Maine and get awful gas mileage. Or you could just drive 65 and do much better. So you want to keep the heat pump at a lower speed and nice and steady, and it'll do the best it can for you for efficiency. Next slide. The remote monitoring that Susan asked me to talk about, I'm going to show just a couple of slides to show what that's like, but clients can control temperature remotely, monitor their electric usage, and get notifications if there's any issues. When we log in, we have a slightly different interface, so we could do all of those things to assist a client if they wanted. But our equipment also allows us to make almost every configuration change that we would make remotely. In person, we can do remotely. And the equipment records data every 10 seconds for how it's operating and any issues and all of that. So it's very powerful. Next slide, please. So this is the client interface if they're logged in. This is actually one of our installations in Melrose. This is a variable speed machine, so it has 12 heating speeds. And you can see in the upper left that it's currently running at speed 4 of 12. This was at some point yesterday when I was making this slide, and it was about 29 degrees out. In the upper middle section, there are 3 thermostats. The equipment can supply, this piece of equipment can actually supply up to 6 different thermostat areas if you'd like, and it's the set temperature and the actual temperature in those regions. And as Jeremy said, leave it on heat until it's time to be cooling, and then leave it on cooling, and you can see that all of these are on heat only. In the lower left, a little bit more information about the compressor speed and fan speed and all of that. And then to the lower center is the actual electric usage of the machine for a variety of different categories at that moment in time. So the compressor using the most power, but the fan and the ground loop circulation also using some electricity, for a total of less than the electricity used by a typical hairdryer. Next slide. Client can look at energy use over time. Here we have a chart that on the left has kilowatt hours, and then it's by month in this case. And we started the system up in November, so that wasn't a complete month. And then December, and now January is nearing completion, but not quite done. You can also look at it on different time scales. Next slide. This is the information as of yesterday for the previous week for that same heat pump, with predictably the higher electric usage being on Sunday when it was colder and pretty darn windy, but varying through the week. And next slide. And that's it. That's the end of my presentation. And whenever it's appropriate, I'm happy to answer questions. Thank you.
What I thought was we would hold the questions until after we hear from everybody, and then we'll do sort of general questions if that's okay. But thank you so much, Larry. So next we wanted to hear from Joe Wood. I think I saw you're on here. Joe, are you here?
I am here. How are you, Susan?
Hi, Joe. How you doing?
Yeah.
So I know you don't have slides for us, which is fine. And I think I don't know if you got my email. What I was thinking, what I specifically wanted to ask you, and I know you do a lot of installations, and you also walk people through how they can use their systems. But to sort of share with us, what you focus on when you're talking to people about how to use their system, and then what kind of questions are most common that you get back from people when they're sort of getting used to using this new system, either in addition to or sometimes in conjunction with an existing heating system.
Sure. Yeah. I think that the presentation that Jeremy had put on is really wonderful, and I want to thank you all for attending and joining, and thank the Melrose HeatSmart program. It's been a great program, and great job working with you, Larry. Jeremy hit all the points really and kind of stole my thunder, but I very much agree with you that you should set it and forget it. I think a lot of people can think about going into a home that's cold and you turn the thermostat, for some reason you turn it up to 85 thinking it's going to heat faster, and a regular system won't, but our system will. It will detect the difference between the outdoor, the indoor request temperature, and it will turn the volume knob up to 10, which is where it runs like you stomping on your gas or something like that. So the set it and forget it concept is very, very important. It is most efficient when it can maintain temperature, and they oftentimes draw comfort like a sine wave of the up and the down, the up and the down. The systems that Larry has and that we have, they're designed more to run like a kind of a squiggling horizontal line, much more efficient if left that way. So that is one of the biggest things I think that is hard to change in the consumer mindset, is because we've been trained for decades to turn things up and turn them down. So excuse me just a moment. We are approaching bedtime and popsicles are on the menu, so excuse me. Another question is about snow, and we haven't had much this year and few amounts of snow last year, but the units are fine in snow. Everything we install is going to be on a snow stand. And even if it weren't, the equipment isn't quite like your oil fill where you need to shovel a path if you had an oil fill. But it is something that you don't want it to get buried in snow, or if you look over and see your neighbor's house has a drift on it, aimed this way, you don't want that to happen, but they're designed to live in the outdoor environment and tested for that. So I think some people think that they're going to need to get out there with a, broom and keep it clean all day, every day. And it's not quite like that. So that's one of the items that we say. However, if you do have a place where tree branches, take, ice on them and then drop them, and it might, potentially damage your equipment. They do sell an item called a hail guard. They're not commonly installed, at least in, our market. They may be elsewhere, but those are available if you had, eaves that drop sheets of snow and things like that. You may consider that. I saw a question come up in the chat about how you would handle different rooms. And the term that Jeremy used about right sizing, that's, kind of the discovery process that we go through to find out how you intend to use your system. If you're an empty nester and the upper floor is not commonly used, it's really just the master and the main living, I'm not against you turning other zones off, but I would like to know that during the design phase so that we design a system accordingly, because the outdoor unit has a variable compressor and it can move a lot of refrigerant or a little, but we need to know how you intend to use it to make sure it's installed well, because some of these systems, you can get 8 zones on one, but if you only ever intend to use one of those zones, it's going to cause malfunctions long-term in the equipment. That would not be a good design on our part if that happened. So, if you've already got a system, our advice would be to try to use the system evenly across all. But if you, again, have that guest room that's just not in use and you're okay with the door closed, it's all right to shut that zone off. Try to maintain at least usage of half of whatever the connected zones are. So if you had a 4-zone system, I would say 2 is kind of a better place. And it's not that you can't break that rule, but I don't think that's the right design for a system for 25 years of usage and to remain efficient. The auto mode is also a topic. Another just comment on that. Jeremy had already covered it. We don't advise that you use it. It's on the remote, which is the same remote sold for a single zone as it is for a multi. In a multi-zone configuration, it can give you nuisance lockouts. It looks at which command is the most recent, and it will kick the outdoor compressor, because while the compressor outside or the outdoor unit, whatever you want to call it, can produce heating and it can produce cooling, it cannot do them simultaneously. So if some unit in the home snuck onto an alternate mode, it would put the remaining units in stasis until it was satisfied, until another call for something like heating or cooling came back. So the long and short of that is just don't use the mode. Air filters, every home's different. If you have a bunch of cats and dogs, or you cook all the time, I recommend a monthly cleaning. It's an ounce of prevention worth a pound of cure. The air filters in the units that we have, they capture allergens, bacteria, and things like that. They will, in part of ductless units particularly, but almost all the Mitsubishi or LG, they don't turn on and turn off. They're constantly moving the air. And as a result of that, they're constantly filtering the air. And you may not even notice it, but it results sometimes. I have this right next door, and the in-law that we put on for my mother, 2 units, and we just never changed them. They're just steady. So that's our advice there. And Jeremy brought up the great point about temperature readings. We do see sometimes the little Brookstone temperature sensor sitting next to a remote control. And one comment I'd have is that the original systems that came to the US from Japan, they didn't even have a readout of a temperature. They just said, I feel, and it was either too warm or too cool, and you just went with that. It's kind of an American thing to be a hawkeye on the numbers there, but these systems, you may find your wall thermostat, which is probably sitting there. If you had to put a unit to 72 to reach 70 there, it doesn't mean anything different. It's just a little disparity in where the temperature is being read. One of them essentially chest level, the other one oftentimes above your head. So that's all that is. The Mitsubishi systems that we install, almost all of them have an occupancy sensor built into them. If you take your remote control, which I don't have one in front of me, but there's a kind of an access door that you can slide up and down. If you slide the door down, there's a little punch that you can poke with a pen or something like that. And it says sensor on it, and you'll see a button toggle on, off, and it's in the manual, and you can call us if you want help. But that IC sensor constantly scans the room, and it can detect a lack of activity, a lack of human activity, and actually automatically ramp themselves back by 4 degrees Fahrenheit. And I think that's a very safe amount to do. The topic about dropping, if you like it at 70 and dropping it to 60, I think is not a good move. You're welcome to do it, but it's not why we put these systems in. And is that sort of usage leads to concerns down the road about why their energy use is higher. So we try to really advise on that. And then the maintenance on the outdoor unit, I definitely think if you are in a clean environment, outdoors where you're not getting pine needles sucked into the unit and things like that, you can definitely make it a couple of years on that. It's the indoors, I think, that need maintenance more often, but you'll know when you're cleaning those filters. But I'd recommend your first year after install, definitely have it checked. It's a pretty cost-effective thing. It's a great way to find out if there's anything coming down the pike that needs to be tended to. But if everything's looking good, it doesn't say this in the manual, but we're okay with you skipping a year too. The landscapers, if they're coming and blowing leaf blowers and mulch and things like that, shut the units off during that period in time. But that's really about it there. And then the last thing is the remote controls, depending on the model you have. Some people say there's 1,000 buttons on there. There are. I think at one point in time, some of the remotes were so simple, people were like, where are all the buttons? And Mitsubishi was like, aye, and they put more buttons on there. Most people use the Kumo Cloud, which is a Wi-Fi app on your phone or tablet, and they just put the remotes in a drawer somewhere. And that's what we like. It's incredibly intuitive to use. It has filter reminders. It will show you error codes and things like that. It allows remote monitoring. And another cool part about it is if you have a 4 or 5 zone system, you don't want to walk around every room and doot, 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 and change the temperature. You can do that through the Kumo Cloud app really, really easily. But even that, you may find the luster wears off because you're not changing the temperature, except for, you're going into April or something like that. And you sometimes don't need a lot of heat, or you might someday want some cooling. That's, I think that's the gist of how we recommend operation and maintenance of the equipment.
Thank you, Joe. That was great. So now I think we'll do a question and answer. I'm going to do the couple that were in the chat, or that people had contacted me ahead of time, and then I'll see if people just want to say something, which is also fine. But we did have a question in the chat asking, at what point does the outdoor cold temperature affect the ability to heat efficiently? I assume it's mostly for the air source heat pumps. That would be the question.
Sure. So the equipment that we're installing is rated to operate at full capacity. And what I mean by that is you hear that word ton, and 1 ton is 12,000 BTUs. So if you had a 3-ton system, you've got 36,000 BTUs on deck. Your system will produce that all the way down to 5 degrees Fahrenheit. And then it begins to taper off. The different models taper to different degrees, but the lowest that you'll see is at 75% of capacity. And that goes down to -13 Fahrenheit. They're actually coming out with a new series of equipment next month, which will go 100% down to -5. The fact of the matter is that's a pure temperature, not a wind chill temperature. And I think we're supposed to see 8 degrees tomorrow. It's pretty uncommon that we fall below there. And if we do, as referenced earlier in Jeremy's section of the presentation, it's probably from 2 to 4 in the morning. By the time you wake up, it's already back up. So these units are capable of being your full scale heating system, provided they're sized correctly, which is an important part of what we do, where we measure your home and size them. So I hope that sufficiently answers that question.
It's to the extent that he was talking about efficiency versus capacity. The efficiency
Right.
is constantly varying with the temperature. Is that right?
That
is correct. And Jeremy, if you want to take that, that's.
Yeah, I mean, I think it's just in general, there, efficient, when the, the difference between the outdoor air temperature and the indoor air temperature increases, the efficiency declines at a pretty steady rate. Most of, the equipment that, the air source heat pumps that have been installed through the Melrose program and the cold climate systems in general are tested to maintain at least, call it 175% efficiency or higher at 5 degrees Fahrenheit. Some will be higher than that, but generally, as Joe said, the both the efficiency and the capacity will continue to decline once you get past that point. But again, in the greater Boston area, we expect there to be something like 30 to 40 hours below 7 degrees or so every year. And depending on whether we get mild winters like the last couple, or we get polar vortexes, that can vary. We have a question. Or sorry, keep going. Go ahead, Susan.
Oh no, I'm just going to go on with the chat question. So are you done with that question?
Yes.
So the next question was, how should the fan speed be set for the splits? And I actually wanted to kind of add to that a little bit. It also, like, if you find that the rooms, like parts of the room are cold, is that something where you would adjust the fan settings for it?
Yeah, so I didn't comment on that, and Jeremy had. I forgot about that. But yeah, the auto setting is the advised position, and also they call them a vane on the wall mount units. That is, it's a bar that can rotate and direct the air, and some of them have different bars that can move, simultaneously in multiple directions. But those will, if left alone, both the vane in auto and the fan speed on auto, it will operate as it sees fit. There are chances due to your home's design or something like that it doesn't make you feel the same across the room, because they'll move air about 30 feet horizontally. But if you're 30 feet away, you may not like the way that feels. So you're more than welcome to adjust the fan speed. And you'll also even notice after time, it will often revert back to auto anyway, because someone forgets it and leaves it on high. So you place it wherever you like. They are still very efficient fans, even when you put them on high. But if efficiency is the goal, auto is the setting.
Okay. Then our next question is from someone saying that they have 2 zones, one on the 2nd floor with 2 units and one on the 3rd floor with 1 unit. So the 3rd floor tends to be warmer, so they've had that unit off. But based on your presentation, it sounds like they should have it on at all times. They wanted to confirm what they would do in that.
And there's scenarios where, every home's different, and you'll have more data on the energy usage. And if you've been quite pleased with it, or you still feel it's a great break from where you used to be, then, power to you, keep going. But if I heard that right, the 3rd floor is its own zone, like 1 indoor unit, 1 outdoor unit. And in which case, left off, there's no efficiency hit there, because you're probably getting a bit of the chimney effect where the warm air is rising to the top floor. I think it would be totally fine to leave that unit off. I don't think that you should run a unit at your own comfort's expense, of course. My advice, if you thought that the turning it off was the better move, just like Larry's equipment, it can actually be the opposite of that. So there's exceptions to all of that, and I'd be happy to feel that offline too. But my general premise would be leave them steady.
Yeah, and I guess what I would add to that is, certainly if you're, if it's such that the units on the 2nd floor and the heat from the rest of the home are sufficient to keep the 3rd floor warm when it's 30, 40 degrees out, leave it off for those periods. The majority of the hours in the winter are above 30 degrees.
I agree.
If you find you just don't need that unit until you get down to 10 degrees, single digits, you're only going to need to run that a few times, on limited times a year. So if you're keeping it off for prolonged periods, and you're getting on just fine with the other units, go for that. It's the constant turning on and off and the cycling up and down that's what compromises your efficiency in the long run.
Yeah, and we also have a similar question. Someone saying they have 5 units, the 3 downstairs run all the time, and the 2 upstairs, they use one of them at night and the other one's off most of the time. And is that okay?
Yeah, and again, it's designed to do this, so it's okay to use it that way. And if you're not feeling unhappy with the way your energy usage is going, then I'm certainly a believer, use it the way you see fit. And I think the way that's described there, where you still have the majority of the system on, I think that's great. I think the example I used earlier, which is kind of dramatic, but it's more just to make the point, if you put in an 8-zone system and only intended to run one of those most of the time, unless it's a really big unit, like, that's equivalent to 25, 35% of the capacity, that's probably not the right design for your home. truthfully. That's something that, there's been a lot of research that large systems, 5 and 8 zone type systems, if they're not designed and used correctly, they can actually be a lot less efficient than people are expecting. So that's kind of what I mean there.
Great. And then we have another question. Do some people remove their boilers? It sounds like we might not run it for years at a time.
Yeah, I didn't touch on that, and I'd written it down to talk about was the term integrated controls. And for anyone who's already had this installed, Massachusetts is offering significant rebates for using cleaner energy technologies like what Achieve offers and New England Ductless offers. And one of the ways with air source heat pump that they're offering great rebates is if you integrate with existing fossil fuels. There's a place, where fossil fuel makes sense, of course, and there's a place where, everything makes sense. It's not throw the baby out with the bathwater. So they have these controls that will allow our systems to work with your boiler. And also you can go without. That's definitely a personal preference. I'm of the opinion that, the removal of a boiler, an oil tank, a set of radiators, it's not cheap, but it's nothing like the cost of putting them back in. So it's always a look before you leap. Make sure you love it. Because if you have a existing radiator system or something like that, there's no enormous cost advantage to rip that out at the same time you put in a heat pump. So I'm a proponent of you taking a wait and see approach to make sure that you love it, because there are people that, love the feel of sitting next to an old radiator that's behind the couch or something like that. And that's totally fine. But we do many jobs where the equipment that we install is the sole source of heat. And to the topic of efficiency, if you were already at a place where your boiler was getting long in the tooth and it's time to consider replacing it, it's very easy to say you're talking about a $10,000 or greater expense. That money put towards a solution like what we offer or Larry offers may be the right move for you. However, if you already had done a system in the last 10 years that's reasonably efficient, I could make the argument that you should keep that too. So it kind of goes both ways.
He followed up with that vis-a-vis removing the boiler. A main concern is the safety of firing up a boiler if you're only doing it very infrequently. I don't know.
So
thoughts on that?
Oh, Larry.
I was gonna say on our projects, the boiler is removed essentially on every time we do a project.
Mm-hmm.
Right.
So for the ground source, absolutely.
And then to that question, I have a master plumbing and gas fitter license and an oil license, and I've done both of those extensively. Those items are designed to withstand enormous periods of non-use. I mean, that's exactly what it looks like going from April to September anyway. There's a design going on there where they're not going to get fouled up. Oil systems, of course, need maintenance annually, and that's kind of like even a car. If you had a classic car sitting around, you still should change the oil. So, but there's no safety concern that would be caused by not using your system for extended periods of time. But if you noticed Larry's slide, he showed a bar graph where it was, I'm a little colorblind, but orange for much of the time, and then there were some red tips. And I suspect, Larry, correct me if I'm wrong, that was maybe using auxiliary heat. That may be how you choose to use a boiler. If you put in integrated controls at 10 degrees or something like that, you could have your boiler turn back on. It will be infrequent, but that's a way you can use integrated controls.
And I think your decision is going to be driven as well by be driven by a number of factors, but the primary ones would be comfort and cost. There's no getting around the fact that air source heat pumps get less efficient as the temperature drops outside. Not the case for ground source, which is why we install them as the only source of heating, and they perform quite well when it's -5 outside. But certainly when air source heat pumps lose efficiency and capacity, there may be times where the fossil fuel boiler is cheaper to operate, depending on what system you have installed, what's the current price of fuels. The utilities, for example, they recommend if you have an oil boiler, that the balance point is around 20 to 25 degrees, but that fluctuates all the time depending on what the cost of electricity is and the cost of oil is. So those, those control, the integrated controls that Joe's referencing, if, oil prices collapse, you can always, run that an oil boiler more. And if they happen to skyrocket, you can run the heat pump more. There are different options there. Let's see, efficiency is not the same as economy. I'm trying to balance the cost impact by turning systems off or set back there or set overnight using gas boiler. It can be, yes, if you wanted to use the gas boiler, say generally a gas boiler, depending on how efficient it is under current energy prices, is going to be cheaper to run in many parts of the winter than electricity is. So certainly, if you're comfortable with doing that sort of operation of having the gas boiler be the primary and then use the heat pumps as supplemental during the day and the evening, that's another that certainly is a viable approach to how you want to run your system. It's just really it's a question of how comfortable are you in doing that, and there also you can also potentially have the controls programmed to do so.
Is that something you can? Is that something you program into the integrated controls, or are you talking about just
that's correct,
setting your own thermostats to?
Or you could do it manually.
Different times. Yeah.
You could do it manually, but yeah, the easiest way, because that would be a duck hunt on some days where the weather's up and down all the time. So integrated controls, you could choose that balance point automatically at X outdoor temperature. The what we would call the legacy heat would turn back on, or you can also use another method where if the heat pumps ever fall behind by a certain amount of degrees, say you want it to be 70 and it's only at 67, it would then engage. So there's a couple ways to use it.
Right. I think part of a lot of this is to say that we're talking general rules of thumb that I think work well for 90-95% of folks. Obviously, there I think are ways to micromanage your energy usage, your controls, your systems to get the most out of it that personally meets your personal needs. That degree of effort is not necessarily what everybody is looking for. Most folks, I find, they want their heating system to work. They want to be comfortable. They want to pay as little as possible to be as comfortable as possible. And these are sort of the general rules of thumb.
Yeah, and I think I've heard from people in the older days, sort of before you had some of the cold climate heat pumps, or where it was really more common to only use them in the shoulder season, people would just turn off the heat pumps for January and only use it sort of but now you have a lot more options to sort of micromanage and use them for hours at a time. We had a question about from Jose Rocker about how we can learn more about integrated controls, because he has a gas-fired steam boiler and a New England ductless six-zone air source heat pump. So
yeah, if you'd like to, I can give my email now, or if you'd like to share that later, Susan, I think I could send you some information.
Okay, I'll get you guys in touch if that works for both of you.
I think the one thing that I would flag for you, Jose, is that the integrated controls incentives that Mass Save offers are only if you have oil or propane. It's not, unfortunately, not for gas, just the way that they do the cost effectiveness calculations for their programs. I think, David, I answered perhaps your second question, but not your first question. You had asked about whether sort of non-hyperheat units, have differences in sort of the efficiency at temperature. I think depending on what model you have, I would say you should expect to get fairly similar efficiency down to around 30 degrees or so, and then performance is and most importantly heating output is going to start declining from that point. If you're going to use compare a Mitsubishi non-hyperheat and a hyperheat unit at 50 degrees, there's probably not going to be very much difference in the performance. Where you're really going to see the difference is at 5 degrees, 10 degrees, 15 degrees. Linda and Bob, I see your question about the auto setting. There are two different places where I think you can run the equipment on auto. You can have the fan speed set on auto so that the fan speed ramps up and down depending on what's needed to meet the temperature in the room. What you should not have run on auto is the heating, whether the system chooses heating or cooling mode. What can happen sometimes is if you have it on auto, it's April, it's 50 degrees outside, the house needs heat, then all of a sudden the room that unit is in gets a lot of direct sunlight and starts heating up, and then now it might go ahead and switch itself to cooling. Or as Joe mentioned earlier, you can get some control issues across the units if you have differences between some of them being on auto or some being on heating and some being on cooling.
Okay, I think we've answered all the questions that are in the chat. Oh, we have one more coming in. Let's see.
How much?
Yeah, I don't understand the question, so I don't know if you want to unmute and ask it. And how much approximate increase in electric bill is normal setting temperature at 70 degrees?
Yeah. Are you asking about increasing from 65 to 70, or are you talking about replacing?
No, so yeah, sorry, I'll just ask my question. So we just got our mini splits installed, and for the first 15 days, bill went up by almost $120. So I'm worried about the next 15 days. So I'm just curious about how much of an increase in the electric bill is normal. So is it like $200 increase from what we used to have? We used to have oil.
Right. Well, the question is, of course, how much did your oil bill decline? Which obviously you don't get that bill every month from the oil company. We would expect that obviously you're switching from your oil bill to your electricity bill, and the net difference between the two should be that you are paying more in electricity, but that's offset by more savings from oil at the same time. So it's hard to give you sort of an exact number there, because it's going to depend on how much have you been using the heat pump for, versus the oil. But it's a pretty, I think Joe can attest to, it's a pretty common thing to when you switch from fossil fuels to electricity. And I'm sure Larry has run into this as well, is that the first thing you notice is the electricity bill going up, but it might be a few more months until you need to get your next oil delivery, and noticing the difference between those two can be hard to see immediately after installation, until you see how much you've saved in oil over the course of the heating season.
I mean, I did an estimate of that. So we spent about $120 a month for oil. So approximately, I was expecting like $150 or $200 increase. But I think one of the biggest thing take away from this is to like set it and leave it. I used to set it back at night, which I should not have been done, and I was not aware of that. So after this, I've removed all my settings for night setbacks.
Yes, sir. Yes, sir. Go ahead, Joe.
As you look at averaging out oil, for example, it's probably the best way that I could think to do it is just take your total bills for the year and then divide them by the 12. And what you're going to see is, like a December, January, oftentimes February are going to be your kind of worst performing months as far as heating performance. The goal, of this really is to amortize this out over the whole 12 months. Because you're going to have, to Jeremy's point, much of the year is really going to be that 30, 40 degree or greater. And those are the times of the year where you really should be earning your dividends. So it's something it's hard to judge on, the coldest months, but it's something I think with proper use and balancing out, it should come out pretty favorably, which is why the programs are, sponsored, because there is a positive impact when compared to oil in particular, but even natural gas in some cases.
All right, do we have any other questions from the audience? You can feel free to unmute yourself if you want to ask it directly, or.
Let's see, Jose, to the extent Jose, are you on a like a discount gas heating rate that
No, it's the regular residential heating rate.
No. You know, I'll give you an example. I live in a 1,100 square foot apartment on the third floor of a 3-decker. So, and the building was renovated to be pretty efficient, and so I pay something like $250 in gas heating per year. So it's the same rate that you would have if you were paying $2,000 a year.
Thank you.
Let's see, Hale, I'm sorry if I missed this, but how does the set and forget it approach match up with smart thermostats? So a smart thermostat, like, you know, if you have a Nest, the idea of the smart thermostat is it kind of learns like when you're out of the home or when you go to sleep, and encourages you to, you know, it eventually learns to like turn down the temperature and such. Well, you essentially, in some respects, it kind of makes your smart thermostat into a dumber thermostat, and that you really don't want that to be going up and down over the course of the day. I know my Nest, you know, it's paired with the furnace, so it has something like 4 or 5 different points throughout the day where it changes the temperature. That's the sort of thing that you don't really want to happen when that thermostat's controlling a heat pump system.
And Jeremy, I think that even with a Nest, if you tell it you have a geothermal system, it will reduce the setbacks or even not use them.
Mm-hmm. Yeah, I think I've got an older generation Nest where it even says specifically it will not work. It only works with single and dual stage heat pumps, which means it's totally not helpful for the equipment that we're talking about here.
I also had a question for you, Joe, from my own experience, because I have a pre-HeatSmart heat pump in a space that we renovated. And is it possible to sort of retrofit like an internet so I can use an app and control it?
Yeah, do you mean a Mitsubishi system?
A Mitsubishi, yeah.
Yeah, they made, within reason, you know, probably going back maybe 10 years now, there's a little connector on the control board that the Wi-Fi accessory clips onto, and it's standard. So it's regardless of unit you have, probably within the last 10 years, maybe longer, but it's ready to go.
It's probably 3 years old now, so.
Yeah, you're fine. Yep.
Okay. All right, do we have any other questions? I think we've gotten everyone from the chat, and I know you can all unmute yourself if you need to. So, well, with that, I'd just like to thank Jeremy.
I have one more question, if that's all right.
Do you have another?
This is not Hale, but her husband.
Okay.
But we just recently upgraded from a boiler system to a heat pump system, and one of the heat pump is in the attic. The boiler was in the basement. The radiant heat from the boiler itself was the heat source in the basement. Do we need now to heat the basement to prevent, what might be the best approach to heating or supplying heat to the basement?
So we definitely recommend that if you think you're ever at a risk of freezing, that you take care of that. It's something that you don't want to have the ambient heat that a boiler used to provide not there any longer, and then risk having something freeze. That would certainly be a bad scenario. How cold would you say that your basement does get? Is it something that's just chilly down there, or are you at a freeze risk, would you say?
This week it's been, the lowest has been 47, but generally around 50 to 55.
Okay. Yeah. And I think, you know, basements, generally speaking, I mean, boilers obviously can make them warmer, but, you know, 65s are pretty kind of steady earth temperature that you seem to see down there. I had the same at our first home, and it was chilly down there, and I had my laundry down there. I'd go down there to do it. Not only was it not terribly comfortable, but I also had mild worry because it was a 1928 bungalow about freezing, but I'd gone through and insulated really, really well. I used mass save and added, you know, the rim joist was insulated, and I used to see a cobweb kind of wiggle when you walk down there. If you're seeing that, I think you've probably got some infiltration occurring. You don't need to provide heat otherwise if you're not, you know, the 47 is safe, and, you know, 32 is freezing. Obviously, if a pipe is against an exterior wall, and you've got 47 in the middle, you know, go check over on the perimeter and make sure that you're not getting down to 35 or something. But if you did have to heat that, what I might suggest, there's a brand called QMark, but they make little like vestibule heaters for when you walk into the entrance of a building, something like that, just to take chill off and set it down to, you know, a temperature that keeps everything safe. You should be good with that.
Perfect. Thank you.
You're welcome.
Yeah, I'm in the same boat with the ground source heat pump that we installed, and we don't have the gas boiler or the gas hot water anymore. So I've have one of those temperature monitors, but so far, yeah, so far we've been above 50, but it definitely might require some air sealing and such in the basement to make sure that it stays above. Hale, did you have a question?
Nope, that was all. Thank you so much. This whole webinar was so helpful. Thank you all.
All right, does anyone else have a question? All right, well, again, thank you so much. This is the last event that we're having in our HeatSmart program, which we are in the process of wrapping up. And it's been a pleasure to work with Jeremy and Joe and Larry, and thank you so much for sharing your knowledge with us today. If anybody thinks of an additional question after this, we are happy to help. You can email heatsmartmelrose@gmail.com, and I will find out the answer for you. But thank you for participating and for supporting the program.
Thank you, Susan.
Great. Thanks,
Thanks,
everyone.
everybody.
Good night, everyone.
Thank you.
Have a good night.
Thank you. Good night.